Hello students, today we discuss Sieve of Eratosthenes algorithm, which is basically an ancient algorithm to find out all the prime numbers within a given limit. So over here we have the document. We use this algorithm in mathematics. So the funda is just like if we have a number set, like for the given limit we set 25. So the task is to find out the prime numbers between 0 to 25. So as we know that 0 and 1 is not our prime number, so we will start from 2. So the funda is that you have to just find out the multiples of first 2, like 2, 4, 6, 8, 10 up to 25. Then you have to mark it 0. Okay. Then you just go to next number, that is our 3 number. So again you have to find out the multiples of 3, like 3, 6, 9, 12, etc. up to 25. Like right now I am just taking the example of upper limit 25. Then you just assign 0 to the multiple of 3 also. Then you have to find out the non-zero next number. That 4 is already taken by 2. Next we have 5. So you have to just find out multiple of 5, like 5, 25. Then 5 2s are 10. It is already covered by 2. Then 5 3s are 15. It is already covered by multiple of 3. Likewise, you have to check out up to 25. If the number is not there, then you ignore this. Then you have to find out next prime number, that is non-zero, that is our 7, and you have to find out the square of it. If the square of the given prime number is greater than our given limit, then you have to stop. So we just go to our algorithm. This is my first algorithm, which is given in the notes. So you have to first create a list of consecutive integers from 2 to n. As we know, 1 and 0 are not prime numbers. Let n be the integer provided by the user. Initially, let p equal to 2. The first prime number is our 2. Starting from p square, count up to increment of p and mark each of these numbers greater than or equal to p square. You can mark it or you can assign a value 0 to it. So these numbers are p into p plus 1, p into p plus 2, p into p plus 3, etc., etc. Like I do that in the case of prime number 2, like 2, then 4, 2 3s are 6, 2 4s are 8, etc. Then find the first number greater than p in the list that is not marked. As we know that 3 is not included. Now we check out for 3 multiples. If there was no such numbers, stop it. Otherwise, let p now equal this number and repeat again. So when the algorithm terminates, all the numbers in the list that are not marked are prime number. In my example, I just put 0 to the prime numbers, not prime numbers, and the values those are not zeros, which these are my prime numbers. Okay, so I have another algorithm also, as you see, to find out all prime under the given integer, that is n. Generate a list of integer from 2 to n. we know that 1 and 0 are not prime number. Start with smallest prime number, that is p is equal to 2. Mark all the prime or all the multiples of p which are less than n as composite. To do this, we just marked 0. Do not mark p itself as composite. Assign the value of p to the next non-zero number in the list which is greater than p. Repeat the process until p square less than equal to n. Okay, like in our case, when n is 25, when 5 is there, that is non-zero element in our list or non-marked number in our list. So 5 5s are 25. We will assign 0 or mark it in our list. So over here is the example. Find all the prime numbers up to 25 as we select the example n is 25. Step 1, generate a list up to n starting from 2. Okay, so over here I just increase the size. So number is 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 25. This is my list. Okay, so as we know, 0 and 1 are not prime numbers. So we have to find out the prime numbers from the given list. So I just go to our next slide. So the step 1 is generate a list up to n starting from 2. So let p is equal to 2 and mark the multiples of p, means 2 is 0 but not p itself. So the multiple of 2 are, so starting from here, 4 assign 0 over here, 6 assign 0 over here, 8 assign 0 over here, 10 assign 0 over here, 12 assign 0 over here, 14 assign 0 over here, 16 0, 18 0, 20 0, 22 0, 24 0. Okay, so like this you have to assign 0 to it or mark it. So over here, as you see, this is the example, and as we know, the condition is p into p should be less than equal to n. In that case, you have to proceed. So as you see over here, so next non-zero prime number is 3. So you have to find out the multiple of 3. So 3 2s are 6, that is already 0. Over here it is 6. So then 3 3s are 9. You have to put 0 over here. Then 3 4s are 12, already 0. 3 5s are 15. You have to assign 0 over here. Then 3 6s are 18, already 0. 3 7s are 21. You have to put 0 over here. Like this, you have to put 0 up to 25. As you see, 3 into 3 should be 9, which is less than equal to n. So we have to proceed to the next non-zero number. So over here I just move to next slide. As you see over here, so the multiples of 2 and 3 are zeros in the given case. Now we should go to the next number, non-zero number. Next non-zero number, that is our 5. So 5 2s are 10, already 0. 5 3s are 15, already marked or 0. 5 4s are 20, already marked or 0. Then 5 5s is 25. You have to mark it 0 also, not 5. Okay, you have to mark multiples, not the number itself. Okay, so as you see over here, you have to put 0. So our prime numbers are 2 3 5 7 11 13 17 19 23. Okay, from and then next number is our 7, and 7 into 7, which gives me 49, which is greater than this 25. So you have to terminate your process. So this is the process how you can proceed for the given algorithm. So next we have to proceed to our program. So over here we have Python program. We have n is equal to my integer. We just get the input from the user, enter an integer number. Next we have a list and the variable name is prime, empty list we have. Then we use a for loop over here, I in range n plus 1. I just get, because I just use n plus 1 because the given n is considered by in our given program, so I just use n plus 1. So append prime dot append iterations. Then as we know, the 0 and 1 is not our prime numbers, so just put assign values to it. So basically it will gives our complete range. This over here from these two lines will give me complete range. So now over from here our program starts, p is equal to 2. So our first prime number, while p into p, it will check the condition like 2 into 2, it is 4, that is less than equal to n, that is in our case it is 25. So if p it is not equal to 0, then it will check for I in range p into 2, means 2 into 2, 4, from here to here, and it is the difference between these two. So basically over here this one append all the numbers one by one from starting 2, because the starting prime number is 2, and over here in this, if prime number p is not changed, then it is a prime number. Okay, so over here in this, update all the multiples of p to 0. So over here we just put all the multiples of p to 0, then print all the elements over here, print all the elements of list which are non-zero. Over here using this program we just print all the non-zero elements in the given list. We just use for I in range len prime, if prime it is not equal to 0, we just use those elements only, because we already provide 0 or mark some value to it. You can use 0 or you can use any another component like you assign 1, you assign 2, you assign 3, and over here you have to just change this, and using this program you can find out your answer. So let's check the answer. So over here I have the program, so I just run it. So it will ask me enter an integer number, as in our case I just put 25. So over here this is my answer, 2, 3, 5, 7, 11, 13, 17, 19 and 23. Again let's check it for another number. Again I hit on run button. So enter an integer. Let's in this case I just use 50. So over here I got the prime numbers. So in this case I have the example of 50, as you see. In this case I have the example of 30, not 50. So let's check for 30 also. So again run it. So the number is 30. So the prime number is 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. So let's check what is the answer. Again 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. So this is how you can use this algorithm to find out the prime numbers. Thank you.